Hi everybody! Within the section Basic Concept of Classical Value Analysis, Block 1 of training course Cost Engineering have already considered the concepts of object of analysis as well as structural and functional models. The role of structural and functional models is to set the degree of abstraction of consideration of the conditional design structure or list of function carriers of component and the complex of inherent functions. The formation of a structural model, as a rule, is carried out on the basis of design documentation taking into account the requirements for the output data of the analysis, i.e., taking into account the information needs of the customer of the analysis. In contrast to the structural model of the component, the main purpose of functional model is a complete or abstract description of functions of the object of analysis, in accordance with the degree of abstraction of the design structure specified during the formation of the structural model, as well as the formalization to relative importance of the functions of the component and the carriers of the functions of which it consists. The direct implementer of the work on the formation of structural and functional models can be both specialists of the design department subject to request from the cost engineers, and they have sufficient qualifications, and cost engineers of first and second and third types themselves, if they have access to the necessary of technical and economic information about the object of analysis. As part of the discussion of today's topic, the following keywords will be used. I recommend the viewers of our channel to familiarize themselves with these keywords before watching this video. The term degree of abstraction is, among other things, used in the standard of DIN 2803, Part 1, Analysis and Formulation of Functions in Value Analysis, Basics and Methods. According to the degree of completeness of the display of the object of analysis, the structural model is divided into a complete structural model, CSM, and an abstracted structural model, ASM. The advantages of a complete structural model can be attributed to the ability to display all structural elements for the object of analysis, except for elements related to exceptions and the corresponding reduction in the error and calculations. The possibility of using engineering methods of analysis, in particular method of factor research, and etc. The disadvantages of complete structural model can be attributed to limitation on the level of complexity of the object of analysis, because the construction of complete structural model is possible only for parts or small assembly units. With an increase in the level of complexity of the analyzed component, the structural model increases in volume, becomes cumbersome and inconvenient for visualization and use in the process of analytical work. A large amount of necessary initial data, including significant costs for its formation, the need to involve various groups of specialists, at least designers, design engineers, and cost engineers. The advantages and disadvantages of an abstract structural model are opposite to the advantages and disadvantages of complete structural model, i.e., in the case of the formation of an abstract structural model, we have a significant error in calculations due to the combination of a significant number of structural elements of the object of analysis into the structural model element. However, from the point of view of visualizing the presentation of information required, for example, admitting of a project manager, an abstract model is the only possible way to present information. In addition, the disadvantages of the abstract structural and functional model include the inability to apply some of engineering methods of analysis, in particular the method of factor research, MFR, and etc. will be considered by us in one of the next issues. According to the volume of technical information content, a structural model can be divided into basic structural model and extended structural model. The advantages and disadvantages of basic and extended structural models are obvious in this case. The most appropriate item term will not be advantages and disadvantages, but limitations of applicability, i.e. the extended structural model is usually used by design engineers during the development of a component or by working groups when forming an action plan to reduce the cost of component of product. In turn, for marketing analysis of preparation of presentation for a new product for the company's management, the amount of information contained in the basic structural model is often sufficient. Due to the fact that the formation of an extended structural model requires additional costs expressed in the labor intensity of design engineers, cost engineers, technologists, and other specialists, a basic complete structural model is usually complied in the first approximation, and then decisions is made of the rationality of additional labor cost associated with the formation of extended structural model. According to the methodology of formalization, structural model can be divided into following types of models: tabular and 2D models, or 2 direct models, in the form of flowchart have become the most widespread in practice. The least time-consuming and convenient in the applied sense, in my opinion, the tabular models, including due to the fact that most people have the skills to work with tabular editors. It should be noted that full-scale layout of structural and functional models, i.e. the creation of physical layouts of function carrier, is increasingly rare in practice. However, due to the presence of advantages in the terms of visualization and the possibility of physical, for example, tactile perception, it may well be implemented at least in the form of real lines on a real flipchart, or real paper cuts or block diagram printed on a printer spread out on a real table, or more expensive ways, prototyping on a 3D printer, etc. The formation of more complex models based on their structural and functional models is currently possible, including in the metaverse, since this tool, coupled with visualization tools, glasses, and other augmented reality generation devices, provided unique visualization capabilities for technically complex objects, for example, motorcycles, cars, airplanes, in a simplified representation. My favorite example is an electric plug socket in the meta-universe, i.e. using augmented reality tools, we can create socket in the meta-universe based on abstract structural and functional models that has all functions of a real socket, i.e. it will have the functions of voltage supply, plug fixing, aesthetic functions, but it will not have a mechanical part in a wiring inside the wall. The logic of this classification, the next classification, completely follows from its name, i.e. we divide structural model and functional model into 2 types: mixed structural model and functional model of basic and optional extroversion, and separate structural model of basic and structural model for optional extroversion, in accordance with the presence of the structural model of carriers, of function carriers, corresponding to the basic and optional extroversion of the object of analysis. The advantages and disadvantages of these 2 types are also shown on slide. I would like to draw the listener's attention to the fact that the terms basic structural model and structural model of basic version are related, but not identical. In the first case, we are talking about structural model which contains basic information sufficient for the formation of functional model based on structural model, as well as basic value analysis reports, a list of which we will consider in the future releases. In second case, we're talking about the structural model describing the basic configuration of the object of analysis, i.e. containing the carriers of function included to the basic configuration and allowing the formation of functional model of this basic configuration, object of basic configuration. The connection between these 2 terms is that when forming a functional model based on structured model of the basic configuration, the formulation will obviously use, among other things, basic functions in accordance with the classification given in issue number 7, object of analysis, decomposition, formulation of functions. Accordingly to the relationship between the terms extended structural model and structural model of optional extra version will be similar. The list of basic initial data for the formation of the structural model of the component can be presented in the first approximation as follows. It should be noted that in addition to technical data, the presented list also includes commercial, design engineering, and other types of initial data. However, in this issue we will not consider the procedure for the formation of commercial components of functional and structural models. Although, in practice, these components take place. Examples of structural and functional models and methods of their construction are described in the university course of value analysis, numerous scientific publications, books, and methodological manuals. Therefore, for a more comprehensive understanding of the issue under study, I would recommend that the course of students familiarize themselves with at least a few examples of building structural and functional models, since the further presentation is built in accordance with a logic of maximum brevity and presentation of a practical bias and the minimum amount of repetition of information already described in existing scientific publication on the topic of the formation of structural and functional models in value analysis. Let's consider a number of examples of basic structural model. As mentioned above, the main role of structural model is to set the required degree of abstraction of consideration. The basic structural model contains information about the designation of function carriers in section designation of functional carriers, subsection ordinal name, full name, and abbreviation. The ordinal name is used in the value design engineering as well in formation of working reports and on the conduct in the value analysis. The full name corresponds to the designation in the design documentation and is necessary for the informational correspondence of working materials of the value analysis and the design documentation. And the abbreviation is used in the formation of value analysis reports and presentation, in particular because in tables and diagrams these abbreviation names take up less space, thereby increasing the readability of information. Accordingly, one of the basic rules in the formation of reference designations is maximum clarity of consonants with the full name. For example, the carrier of bold head function, it's recommended to shorten head or HD. The presented slides show examples of 4 degrees of abstraction of consideration on the example of a bicycle, mountain bike. See the column component. In particular, the slides show an abstract model of bicycle divided into 10 positions and abstract model of front wheel of a bicycle also divided into 10 positions and abstract model of wheel bushing, housing, and complete model of bolt. In this case, the discrepancy of number of positions is caused to the fact that the first 2 cases the degree of abstraction is set, so the number of structural elements function carriers of analyzed object is a given round number, and in the 3rd and 4th cases we are dealing with a complete model of bolt of the and object of analysis and an abstract model bushing, housing close in the content to the full model. For these 2 models, the number of structural elements or carriers of functions is already related to the degree of complexity of the design and not to our desire and convenience. Let me explain why the voluminous and first glance comprehensive structural and functional models front wheel bushing are abstract. In addition to the definition of a complete model given in issue number 7, object of analysis, decomposition, formulation of functions, the following definition can be given. We will call a complete model a model of which all constructive, i.e., corresponding at least to the design engineering documentation and, if necessary, subjected to additional decomposition, carriers of functions for which their functional significance can later be determined, the cost of their implementation or implementation in the design of component and other characteristics. In structural and functional models, some of the same type of completely identical carriers of function are designated in structural model and functional model as on. In this case, we are talking about fillets, about only constructive ones, because we do not introduce technological ons into model. For example, spoke flanges, holes, frills, etc. i.e., we define all these above characteristics not for one element, but for their set combined in the model under the designation of a common carriers of functions. Thus, the functional model of Buschenhausen is still not complete despite its visual complexity and volume. The essence of considering functional model Buschenhausen, generally speaking, is precisely to demonstrate the real volume of tabular functional model relative to a complex part and the complexity of its formation. Structural and functional models, simpler parts of both, in turn, fully meet all requirements for full models. Bolt and Buschen models are an example of lower-level models that can be used in the value design engineering process as opposed to abstract upper-level models, which include models of a bicycle and its front wheel. Unlike abstract models of a bicycle and the front wheel of a bicycle for which visualization were made, in my opinion, it's not required. We will consider the Buschenhausen and Bolt in more detail, simultaneously noting individual features that relate directly for functional cost design or value design engineering. In particular, the above-mentioned Buschen is presented to your attention. For listeners who are not familiar with 3D modeling, we know that the construction tree is located to the left of 3D model field. This is construction tree, which contains elements of construction, stretching, subtraction of bodies, rounding, auxiliary geometry, and etc. So, as a rule, this tree either simply corresponds to order of construction or is ordered according to some things, to some science that the design engineer follows for its own convenience. For example, when I was working design engineer in aerospace industry, I created a reference set of geometry, combined it into a macro element and called it skeleton, because I met such a designation when I studied 3D model in one of textbooks. Then the elements in the tree were arranged according to the construction. In addition, I renamed individual elements in 3D models tree for my own convenience, so that after opening the model after some time, for example after a year, I could understand which element of the auxiliary geometry relates to what. In value analysis, the approach to the formation for the construction tree is somewhat different. As we can see, all the elements of the construction tree are combined into macro elements. This layout is an element of value design engineering methodic. It's not performed during typical design process. Corresponding to the structural tabular model of the Buschen, which we considered earlier. If in the CAD interface that's used for modeling there are no possibilities of marking the coding, for example, or advertising labels, and etc., they can be made in any accessible way. For example, in this case, I made advertising labels and coding using item designation for the base of roughness. The main necessary property of which taken into account my goals in visual visibility. In practice, information about the properties of the object of analysis can be presented in the technical requirements of drawing of model and visually absent in the working field in different programs in different ways. In this case, the idea comes to the mind about the possibility of forming a special model in CAD designed for use in value design engineering process, i.e. the model that allows you to automate the process of forming structural functional models as much as possible, as well their unloading for further generation of value analysis reports. The concept of forming such a model will be considered by us in one of the future issues of Block 2 of our course. As we can see, this approach to the visualization of function carriers in Model 3 assumes the maximum possible geometric and visual correspondence of the elements of the structural tabular model and the 3D model. Due to the fact that the Bushian functional model refers to abstract in a 3D model as a tabular functional model, all elements of the same type, threads, holes, blends, are either combined in one function carrier without sub-elements, or they are combined and have sub-elements corresponding to the level of the complete model. Of course, the second option is preferable, although more time-consuming. With the bold, respectively, the second option takes place, i.e. each element of the bold structural model related to the complete structural model is shown on 3D model construction tree, as well as in a tabular structural model. In the case of the formation of an extended structural model, the sections information based on design documentation, project data, and commercial data are added to the section of the basic structural model. According to the section information based on a design documentation, it can be noted that almost all fields are filled in based on design documentation data, in particular drawings of 3D models, specification and technological documents, if they are available. According to the section project data of the extended structural model, the following can be noted. The volume of the product life cycle for the carriers of the functions of a complete structural model is not specified in this case, since it's impossible to produce one of the elements of an indivisible part separately from others. For two variants of abstract structural model, the values of the in this group of parameters may differ due to the fact that some elements are produced during the life cycle and some of consumables they are produced several times during the life cycle. For example, brake pads, tires, etc. One-time costs or costs of production equipment or R&D for individual components are equal to 0. This is due either to the fact that we use standard of purchase products and the design, bearing, camera, tire, saddle assembly, transmission, suspension, or to the independent production for the product of stencil or laser cutting on universal equipment, for example, flipper, brake disc. Thus, we see another role or the extended structural model. In addition to setting the degree of abstraction is the formation of more comprehensive view of the object of analysis. According to the commercial data section of extended structural model, the following can be noted. For standard or purchase products, there is a dash in the ERP column. Since it's often impossible to obtain a calculation from the production side of third-party manufacturers or purchased or standard products. In practice, a cost engineer often encounters cases when there's a need to reduce the elements of structural model. In this case, the method of distribution basis is used. In more cases, this technique is used in the case of working with abstract structural models, since the use of the distribution-based methodology is a simplification that introduces some inaccuracy. Therefore, when we work with complete models, its use is undesirable. Its use is undesirable. An example of the application of the distribution-based methodology can be already discussed above. An abstract bicycle model, which currently consists of 10 positions. It's logical to start the process of distributing elements and in fact the process of simplifying the model and therefore introducing additional error into it. With the least expensive standard elements that are physically distributed by construction of bicycle, usually they start with fasteners, harnesses, and other standard products. In our case, these criteria are met by the carrier function number 5, the braking system, and the carrier function number 10, lightning bell winds. Moreover, as physical carriers, they can be distributed fairly evenly among the other carriers of function. In particular, the brake system consists of 2 control mechanisms and 2 calipers, easily distributed between 2 wheels. We neglect the difference in the lathes of hydraulic or mechanical highways, with the distribution coefficient of 0.5. 2 winds and lighting equipment are also distributed on wheels with coefficients 0.5. Forced simplification includes the fact that we neglect the price of the coal, since we do not have information about this price, separated from the carrier of function 10, and we refer the tail light to the wheel, although in fact is installed on the saddle node. Thus, we get a simplified structural model of a bicycle consists of 8 most expensive carriers of functions, which can be later used for analysis and forming value analysis reports. By analogy with structural models, in terms of the degree of completeness of the display of the functions of the object of analysis, functional model can be classified as follows. The advantages and disadvantages of abstract and complex functional models shown on the slide logically follow from the advantages and disadvantages of abstract and complex structural models already discussed above. In particular, the complexity of forming a complete functional model is due to the level of abstraction set of the formation of structural model, i.e. the more number of function carriers we consider is more functions can be formulated and the more cumbersome the functional models will be. A similar approach is also used for abstract functional model, which being small in size can be used to form visual materials, presentations, videos, paper reports, etc. However, if any conclusions are formed on their basis, the manager may face the problem of too general or too abstract conclusions and the corresponding too general or too abstract solutions. For example, the conclusion, the reason of the high cost of our mountain bike is due to the high cost of wheels formed on the basis of an abstract bike structural model and its functional model. And the corresponding economic value analysis reports on the costs of the functions carriers is in truth too general, and the effectiveness of this report as well as the result, effectiveness of this manager, looked doubtful. In this case, the structural and functional model of the bicycle should be clarified by introducing basic and additional options, or in accordance with the terminology of the value analysis, basic and additional functions. For example, the manufacture of standard and double wheel rims, the manufacture of aluminum spokes and stainless steel spokes, etc. Accordingly, the structural and functional model presented to the manager becomes somewhat more voluminous, but in conclusion, about the possibility or impossibility of reducing the cost of wheels becomes more meaningful and become deciding on the direction of design and other resources for the development of an action plan to reduce the costs. He can consult, for example, with marketers or designers or design engineering specialists about the need to use the basic designs of bicycle has double rims and spoke made of stainless steel, as well the possibility of their exclusion from the design of making additional options. Thus, we do not overload the manager with unnecessary information while at the same time not putting him in the position of talking head, issuing a decision on the need to reduce costs without sufficient prerequisites for carrying out of analytical and other work in this area. Based on the above function model classification according to the degree of completeness of object of analysis and the above mentioned reasoning, the following conclusions can be drawn about the applied significance of using the value analysis in the management system. The first, the use of value analysis, in particular structural and functional models and standard value analysis reports, in such areas as management, accounting system, conducting technical, economic and commercial negotiations, as well as project management, allows you to regulate the information workload of the manager. Thus, being an effective practical tool for preparing management presentations and reports on the basis of which management decisions can be made at various levels, starting from the level of general director of project manager, ending with the level of the design decisions. The next, based on the above conclusion, a consequence can be formulated containing for formulation the method of forming abstract functional models using cost drivers. Since abstract structural models using cost drivers are usually used by top managers in the decision-making process as part of presentation of the value analysis report, an appropriate definition can be introduced for this type of models: abstract functional and model and abstract structural model, simplified to the degree of abstraction, allowing to provide a level of visualization acceptable for the purposes of presenting the results of value analysis to the management of the enterprise, and including the main cost drivers of cost reduction are called adapted structural and functional models. Adapted structural and functional models can be formed by the following expert method, with allows in the first approximation to dispense with the formation of complex structural and functional models of a lower level, especially since in most cases there are no time and other resources for their formation, since one of the requirements for the management accounting system is the speed of providing information. The process of formation of adapted abstract structural abstract functional models includes the following stages. The first, formation of abstract structural and functional models of the object of analysis consisting of 10 elements. The number of abstract and functional and structural models elements is chosen arbitrarily, based on practical experience in the providing analytical information to management. Abstract structural and functional models with a large number of elements, after being supplemented with cost driver functions, may become too cumbersome in connection with the due to quality of their visualization may be reduced. The next, formation of standard of special reports on the conduct of the value analysis for the current versions of abstract structural and abstract functional model determination. The next, third, determination of the cost drivers for reducing component costs, for example, by applying the method of factor research (MFR) based on the expert evaluation of designers, brainstorming, and etc. According to the result of the stage, cost drivers should be formulated in the form of abstract functional functions, i.e., for example, in the case of a double rhyme, the function will sound to provide special requirements for strength. in the case of stainless steel spokes, to provide special requirements for corrosion resistance, and etc. The next modification, if necessary, of the abstract structural and abstract functional model, as well as the source data or initial data for analysis. It includes expert and actual calculations, commercial proposals, design, engineering documentation, and etc. And taking into account cost drivers. The next, formation of structural, of standard or special reports on the conduct of the value analysis on the basis of modified abstract structural and functional models. The next, comparison of reports on the analysis of the original and modified design components. The next stage is a consultation with the participants of the project working group based on the modified abstract structural functional models and value analysis reports. And the last stage is making a management decision, continuation or completion of the project, or completion or continuation of commercial negotiations, carrying out cost reduction measures, and making appropriate changes to design and technological documentation. According to the results of the abstract functional model adjusted by adding cost drivers to reduce costs, the number of abstract structural model elements as a rule remains unchanged, and the number of abstract functional models of the product component increases to 15-20. An example of the formation of adopted abstract structural and abstract functional models will be considered by us in a separate video of Block 3. Applying the analogy method, we will consider the possibility of classifying functional models according to the criteria that we used to classify structural models. In terms of classification by the volume of technical and economical information, by content of base and extraversion options, and by the method of object of analysis formalization, it can be stated in the first approximation that functional models can be classified completely similarly to structural models. Functions from the block of special functions, as a rule, are used by design engineers in the process of developing of a component, i.e. in the process of value design engineering, to clarify the functional base model, assess the degree of novelty of object of analysis, marketing analysis, cost estimation for life cycle, and etc. Working groups, when forming an action plan to reduce the cost of a component of product, project managers, marketers, cost engineers of second and third types in the process of generating reports for managers of various levels, as a rule, use only basic functional models in their activities. Due to the fact that the formation of special functional model requires additional costs expressed in the complexity of designers, cost engineers, technologists, and other specialists in the first approximation, a model is usually compiled containing only functions from the block of general functions, i.e. Consumer and technical and operational, and then a decision is made on the need to supplement it with special functions. The problem of working with special functions, the problem of working with neutral and harmful functions is the need to determine their significance and allocate costs for their implementation, which is usually a more difficult task than determining these parameters for functions from the block of general functions. With regard potential functions, as a rule, their problems is solved more simply. They are referred to as additional or secondary functions and are included respectively in the functional model of basic or additional configuration. In the cases of block 2, 4, and 5, and 6 of the course, cost engineering cases of analysis object containing special functions will be considered. The presence of a formed structural model and the initial data used in the formation is necessary but not sufficient for the formation of a functional model. On the slide, a table of initial data necessary for formation of functional model of the object of analysis is presented. Despite the fact that in issue number 6, information provided in value analysis, structural and functional models were assigned by us to one category of initial data, namely the category of derived initial data of the second order. However, there is a significant difference between these two types of information models expressed in the composition of the work performed during their formation. For structural model in particular, in the process of structural model formation, the technical qualification of a specialist and his skills in working with design and technological documentation, as well as commercial information, are important. For functional model, the process of functional model formation in turn is characterized by a shift in emphasis from the technical slide to the field of conducting surveys of specialist in marketing analytics in terms of determining the degree of satisfaction with functions, reliability analysis, FMEA analysis, for example, determining the significance of functions by various methods and subsequent analytical work. The indicated difference in the list of necessary documentation, the composition of the work, and the list of main and auxiliary specialists involved become especially noticeable after compiling and comparing the list of initial data necessary for the formation of structural and functional models. With regard to the applied tools for the formation of structural and functional models, I will make a reservation that, for example, I use in practice exclusively tabular structural and functional models formed in the environment of tabular editors, which is due firstly to the considerable complexity of the formation of structural and functional models by other of the indicated methods. Secondly, to the fact that the most of the reports I generate in a tabular editor only later form in a text graphic report in a text editor. For example, on this slide, based on the results of formation of complete and abstract models of varying degrees of abstraction, it's possible to draw some parallels and propose an alternative formulation of the concepts of structural and functional models, or rather to combine them and other models used in the functional in value analysis into one definition: a set of formal logical models of a component products object of analysis, or CFM. It's not complete functional model, but it sounds and written similarly. CFM is a complex of formal logical models of a component, including at least structural and functional models, information, tabular, mathematical model, formed on the basis of intermediate graphical models, 3D models, drawings, specifications, and etc. Intermediate graphical models is 3D models, drawings, specifications, layouts, and etc. represent a separate category of models, i.e. they do not formally belong to mathematical information models, but a complex of models which we have designated as CFM. Intermediate graphical models are mainly of applied value and other initial data for the formation of complete no, complex of functional models. In a colloquial language among Russian-speaking engineers, and especially among management of various levels, you can hear the term mathematical model or its variation, math model, applied to the 3D models. Formally, such use of this term is incorrect, because according to the classification given in open sources, all models can be divided into 4 categories: heuristic, full-scale, mathematical, and intermediate. 3D models in particular, as we have already noted above, refer to intermediate graphical and now not mathematical models. From an applied point of view, it's possible to formulate the local purpose of introducing the term of complex of formal logical models, a set of design documentation is 3D model, drawings and specification, and LEDs provides an almost complete list of information for the formation of structural functional models. Therefore, when forming a CFM, we actually duplicate a set of design documentation and presenting it in an alternative form that allows to generate analytical reports or conducting value analysis for various users, primarily design engineers and cost engineers. In particular, designers or cost engineers of the first and second and third types translate design documentation into the form most convenient for calculating and forming various graphs, diagrams, and analytical reports. In this case, tabular. Indeed, if we compare the convenience of perception of two calculation options, the first in the form of a structural functional model with an added column containing cost units, and the second in the form of drawing of 3D model on which next to each tolerance, each roughness icon, net the freed, etc., the costs of their implementation will be assigned. The strategic purpose of the introduction in the term of complex of formal logical models is the conditional goal of marketers, project managers, company management. This strategic purpose is to control the cost of a component or products by generating management reports based on the currently available design documentation, commercial information, and information generated by the results of the implementation of projects similar and specifics in previous periods. In the issue of Block 1 entitled Value Analysis Information Database, we will talk in particular about the storage of complex of formal logical models. We can see two consequences of the conclusion based on the results of formation structural functional models. Based on the above conclusions, the following consequences can be formulated. Consequence 1. When forming structural and functional models, the methods mentioned by us in this issue and issue number 7, Object of Analysis, Decomposition, Formulation of Functions, their limitations and exceptions, regulatory documents, GOST 2.316 to 008, can also be used since it contains recommendations on the formulation of individual properties that form the functions displayed in the functional model of the object of analysis. Consequence 2. With an increase in the degree of abstraction of the consideration of object of analysis, we actually exclude information about the object in order to reduce the volume of complex of formal logical documentation, or complex of i.e. if we draw the rough analogy, we analyze the design of object of analysis, draw conclusions and make decisions having only its assembly drawings as a part that lacks some of the necessary information that is incorrect drawing of 3D model. The next consequence, the presence in the technical specification of 3D model drawing or specification of information not displayed in the full structure and functional model and not related to the limitations and exceptions described in this issue and issue number 7 may indicate that the structural and functional model do not fully display the information content of the design documentation and refer to complete models formed with an error, i.e. actually to abstract structural and functional models. And the last consequence, one of the mandatory or routine functions of the cost engineering division will be to the translation of design documentation from a standard form, technical specification, 3D models, drawings, and etc. into the form of tabular information models. Therefore, one of the requirements for specialists of this division engaged is in carrying out these works will be the experience of design engineering activities. Okay, let's consider the methods of increasing the degree of abstraction of structural and functional models. In context of changing the degree of abstraction of structural and functional models, let's consider the concept of modifying full structural and functional models into abstract ones. An example of the method of simplifying of a complete structural model to an abstract one is the method of distribution basis discussed in issue number 7, used in the formation of abstract structural models. When simplifying the full structural functional model to abstract ones, the method of function aggregation also can be used, i.e., instead of forming several functions related to a certain block, type or group of one function, the formulation of which would cover the data of several functions. When forming an enlarged function, it will obviously be necessary to change the wording, which is additional factor is increasing the complexity of work on simplifying full functional model to abstract ones. In more detail, the process of translating structural and functional models of full to or average level of abstraction into structural and functional models of the top level of abstraction or higher level of abstraction will be considered in the practical cases of Block 2. It should be noted that this operation to increase the degree of abstraction is very much in demand in practice, since managers at various levels often have to hear requirements for analytical reporting containing requests for compression of visual information. For example, presentation of the current cost of a product in the form of from 5 to 10 indicators, on the basis of which is possible to assess the degree of implementation of target project indicators and strategic level. Methods of decreasing degree of abstraction of structural and functional models. The first thing that comes to mind when asked about methods of reducing the degree of abstraction, i.e. the approximation of abstract structural and functional model to full or to complete, is to increase the number of elements in structural model, i.e. decomposition of function carriers in structural model and functions in functional model. To the level of compliance with design documentation, i.e. conditionally to bolts, screws, rivets, parts, and the corresponding increase to the number of functions in functional model. The difference between the process of reducing the degree of abstraction from the process of increasing of its emergence of new for additional information, we return the question initial data for the formation structural and functional models, which we considered in issue number 7. In this case, the requirements for the volume of initial data depend on the task. The task more from abstract structural function model to complete, then there is a new for a complete set of design documentation synth, the case of using special databases from disassembly and some others sources of information. We can only for abstract models close to full. Further, when moving to full to complete structural functional model, as a rule, there is a need for decomposition carriers of functions in structural model by the methods of conditional volumetric carriers of functions, CVCF, that we described above in issue number 7. If the task is to reduce the degree of abstraction but not to the level of complete structural functional model, then the amount of source or initial data may vary, i.e. a complete set of design documentation in many cases will be superfluous. In addition to the above 4 logical consequences formulated based on the results on the formation of structural and functional models of varying degrees of abstraction, a basic criterion of correctness or BCC of classification of structural and functional models can be formulated. The use of the term basic in one case is aimed to emphasize that in the first approximation the set of structural models can be divided into two sets, full structural and abstract structural models. Similarly, the set of functional models can be divided into two analogical sets, full and abstract functional model. So, the basic criterion for the correctness of the classification of structural and functional models of a component or a product, i.e., attributing them either to abstract to complete models, is the possibility of performing a reverse design, i.e., forming design documentation, or design and engineering documentation based on them. It's 3D models, drawings, technical specifications, and etc. Generally speaking, this thesis as a rule is not mentioned in the works devoted to value analysis, in particular when considering practical examples given in these works, and indeed using the example of the bolt and the sleeve discussed above. It can be argued that structural and especially functional models of even such structurally simple elements may contain dozens of functions. Consequently, the components that include in the bolt and the bushing or sleeve when construction component models may contain hundreds and even thousands of functions and accordingly cannot be visualized within the framework of textbooks of a course of lectures. Therefore, we come to the conclusion that if we have the structural and functional model of component containing, for example, dozen carriers, 2 or 3 dozen functions corresponding to them, i.e., obviously there are fewer functions inherent in complete structural and functional models of a certain level of complexity, which means that we have either a training model aimed to demonstrating the principle of analysis, or complete structural or functional models simplified to the form of an abstract model. In all other cases, it can be argued that we are dealing with abstract structural and functional models, that correctness of which, and consequently of conclusions formed on the basis of these models, cause serious doubts. Okay, we've got some risks about all these sections. Complete structural and functional models, as we have already mentioned, are mainly used by cost engineers of the first and second types, whose activities will be considered as by theoretical calculation and practical cases related to the block 2 of our training course. Abstract structural and functional models can be used both in the activities of first, second, and third types of cost engineers, and in activities of chief designers, project managers, designers, managers of various levels, marketers, and etc. Thus, we come to the conclusion, first of all, about the important role of the business process of interaction of the above-mentioned departments, in particular, the business process of the request to the design department, either complete structural and functional models or simplified structural and functional models. The work on the formation of complete or simplified structural and functional models as part of the design department will be carried out either by type 1 cost engineer, or by a value design engineering unit as part of the design department that has type 1 and type 2 cost engineers in its composition. Separately, it should be noted that the use in the process of making managerial design decisions based on analytical reports prepared using abstract structural and functional models formed in isolation, i.e., without the use of complete structural and functional models as subcomponents, complete structural and functional models at the lower level, carries significant risks, since these analytical reports are highly likely do not reflect an actual state of things. In more detail, cases of using abstract and complete structural and functional models in the activities of departments corresponding to the blocks of training course cost engineering will be considered in practical cases. The limitations of the application of the basic criterion of the correctness of the classification of structural and functional models can be attributed to the first approximation. Abstract consumer structural and functional models formed during the consumer's decision-making process when there are several analogs of consumer goods on the market, i.e. since in this case when buying a bicycle, motorcycle or car, the consumer cannot request a list of complex structural and functional model components from the product developer. He has to make a decision based on consumer structural functional models related to abstract models formed on the basis of information available to him. The second, abstract structural and functional models forming internal and external negation bases. Its second restriction cares about structural and functional models formed as a process of commercial negotiations with the supplier of purchased products for which the supplier does not provide a complete list of information. It's a simple case. In particular, complete factory calculations, design documentation, and etc. It should be noted that the need to make a decision in conditions of information scarcity, it's typical for the process of commercial negotiations in most cases. Third restriction cares about abstract structure and functional models formed when setting the target price of analyzed object that has a high degree of novelty, i.e. when it's impossible to comply the principle of continuity of product generations during design, absence of complete structural and functional models for products over the previous generation of analog products developed by competent companies. All three of the above cases of the formation of structural and functional models are narrowly focused on self-sufficient, i.e. in all three of these cases, the formation of complex structural and functional models is either impossible or has no practical, technical, and economical effect. In fact, in all these cases, analysts are limited to the formation of abstract structural and functional model of varying degrees of abstraction, so the basic criterion for the correctness of basic BCC of the classification of structural and functional models does not make sense. A practical case of applying the rule of standard technological elements and the rule of avoiding surfaces discussed by us in issue number 7, an example of a complete model of a bolt with a head and an external hexagon key seat can be considered. Depending on the possible basic manufacturing technology of this bolt, powder technology, milling, casting, planting, various combination of basic technology with additional operations will take place. Electro-erosion, manufacturing of bolt head hexagon key seat, threading, thread rolling, laser marking, and etc. Nevertheless, the use of all these listed manufacturing technologies implies the presence of such technologically determined structural elements as the radius of rounding between the head and the shank, the thread exit zone, the chamfer of the lower end, and the rounding inside the recess and between the edges of hexagon-shaped place. We do not include all these listed elements in the structural and functional model in accordance with the rule of standard technological elements. Let's assume that all the listed manufacturing technologies provide by default a manufacturing tolerance for smooth part of the H12 bolt rod, bolt shank. Thus, if the bolt we are considering has age 12 feet, then we do not add it to the functional model. If the bolt has a feet order other than age 12 with a default roughness of RA 6.3, in our case H7 tolerance with a roughness RA 1.25. Then in accordance with the surface avoidance rule and the rule of standard technological elements that we enter in number 7 issue, zone of the smooth part of the bolt with the tolerance of H7 is present in the functional model, and the corresponding one is by default. The roughness of RA 1.25 is mentioned in the formulation of the function, but it's not introduced as separate function of functional model. It should be noted that the component we have taken as an example, the bicycle front wheel bushing housing, is quite complex from the point of view of forming complete functional model. One of the consequences of this switch is torque buckness of the component tabular model of this component. In this regard, in order to limit the representation of the complete functional model bushing housing to one slide, we will consider a simplified model which is actually abstract, but in any case superior to the other two examples, front wheel and bicycle. In terms of the number of degree of detail of functional considered as part of the consideration of Block 2 of training course Cost Engineering, we will consider simpler components and design for which a complete functional model will have no more than 20 positions in order to avoid consideration of excessively cumbersome and not visual complete functional models in practice. Such as an approach also takes place, and it's manifested in the application of the decomposition method in the design process, which is expressed in the fact that we divide assembly units into parts or small assembly units, the full functional models of which have a size of more than 20 positions. In the case of automation of the process of formation and analysis of structural and functional models, for example, by using artificial intelligence, AI, in their formation, such restrictions lose their relevance. The issue of the formation of basic and optional extroversion in the formation of structural and functional models is quite an important issue, which as a rule is also not given attention to the publication in the university course of value analysis. In part, this may be due to the fact that the need to take into account the basic and additional equipment, as a rule, arises precisely in the practice of the value analysis as well in the process of the value design engineering. However, the fact that when the structural model is supplemented with this functional carrier, that is additional or an optional extroversion, significantly changes in the picture, not only in the structural model, but to greater extent in functional model. In the following discussion, the concepts not yet considered in the theoretical part of the cost engineering course will be used, as well as the classification of structural and functional models voiced above according to the content of the function carrier, basic and additional options or mixed structural and functional models of the basic configuration and structural model and of optional extroversion configuration. And according to the content of the basic functions listed in the technical specifications for the development of the object of analysis, the general logic, I think, will be clear to the listeners. Okay, what about disadvantages of mixed structural functional models in basic and extroversion computations? Consider the following example. For the basic configuration of product, structural and functional model are formed. For this product, there are calculations of technical commercial proposal that allow you to generate reports containing values of relative significance of functional model functions as well as the corresponding relative significance of the functions carriers from the structural model. In addition, during the analysis, the costs for the formation of basic functions, the cost of the physical implementation of basic functions in the design in engineering documentation, and the costs of each of the functions carriers in structural model basic configuration were determined. Further, two additional functions carriers corresponding to optional extraversion configuration were added to the structural model of the basic configuration. Accordingly to our structural and functional model are transformed from structural and functional model of the basic configuration into mixed structural and functional model, in which the indicators of the significance of the functional model functions must be adjusted, which leads to the need for a complete recalculation of all the parameters defined for structural and functional models of the basic configuration listed above. It's first case, and there's a case after recalculation. No, I think it's simple mathematics here, and it's okay. Thus, we come across the main disadvantages of mixed structural and functional models, which is that without fixing the values of the relative significance of the basic functions, the cost of implementing functions, etc., for structural and functional model of the basic configuration, we get floating values here. It's floating values for analogical components. Or significance of the basic functions of the costs associated with their implementation with any changes in the composition of structural and functional models. For example, in accordance with the report of the value analysis of the basic structural model of the hypothetical object of analysis, report number 1, the relative significance of the base function carrier number 1 carriers was O.1. The next, and the relative significance of its functional base function number 1 and the base function number 2 were equal to O.05 and O.03 respectively. When an extraversion, additional options, is introduced into the basic configuration as an additional carrier of functions is introduced into the structural model, and the corresponding functions are introduced in the functional model. So when recalculating the significance, report number 2, all the above-mentioned values of the relative significance of the basic functions and their function carriers will float. Thus, when working with mixed structural model, functional model containing additional options, we are faced with an absurd situation when the same carriers of basic configuration functions and their corresponding functions have different significance and different costs for the physical implementation of functions in the component design. Of course, this moment is a working one. However, if the significance values of the same elements jump regularly at the management meeting, and the management does not have memory problems, and the reputation of such analysis technique, and therefore yours, may be damaged. Thus, we come to the conclusion that the use of mixed structural and functional models in the situation of the presence of basic and additional options is not desirable. What about practical reflection of optional extraversion? The structural and functional models given by us in this issue are mixed to the classification of structural functional models according to the content of function carriers of basic and additional options given above. And accordingly, there is no visual division into basic and extraversion options, except for the designation, whereas in practice in the value analysis and value design engineering, the separation corresponds to the above. The structural and functional models classifications, i.e. the media and functional corresponding to the additional options are separate structural and functional additional options. These nuances will be considered by us in the theoretical part, i.e. in section 1 of block 1 and the framework of practical cases of block 2, 3 and 5. We come to the conclusion that mixed structural and functional models can be used if we are dealing with the abstract models or permanent composition. But if there are risks of changing the composition of structural and functional models, which is extremely common in practice, it's recommended to separate structural and functional models for basic and optional extraversion. The disadvantage of such solution is a great complexity of the formation and recalculation, as well as the visual volume of separate models compared with mixed models. In accordance with the classification set out in issue number 7, functions intended to highlight elements related to optional extraversions are additional, secondary technical, and secondary operational. When considering the functional elements or carriers of functions of the Bushin housing, but intended for touching the disk brake, we consider the disk brake as an extraversion option in order to demonstrate in this example of the functional model of a complete list of types of functions within the framework of the classification announced in the previous video. In this case, we consider the pincer brake mechanism to be the basic function which is not reflected in functional model of front bushing level, since it's not structurally related to it anyway. We can find the application of the practice of extraversion options is most of branches of general mechanical engineering, automotive, aerospace, railway engineering, etc. The simplest everyday example when we encountered additional options is the purchase of a car or motorcycle. On the dealer's website, options are usually presented in the form of names, prices, so the pricing scheme for option remains, to put it mildly, not completely transparent. Perhaps one of the practical cases of Block 5 will be devoted to the issue of pricing options for ready-to-sell product, car, motorcycle for such a dealership. I suggest we end this for today. Put likes, subscribe, all bye.